So not long ago we treated geometric arithmetic sequences. In this video we'll be treating geometric sequences. And a sequence is said to be geometric, right, if there is a constant such that the constant is called the common ratio, right? It means that if you take any two subsequent terms and you find the ratio, it's a constant, right? Now the sum of the first n terms of a sequence is given as this, right? Of a geometric sequence is given as this formula. A multiplying 1 minus r raised to the power n all over 1 minus r, right? I believe it's also taught in SHS, right? But there's the formula where A is the first term. So for example, you are given the sequence 1, 1 over 2, 1 over 4, 1 over 8, right? Now, usually don't just go and say the sequence is geometric, right? Try and test, right? So first I test, let me take any two of them, right? So let me take the previous term, preceding term and the previous term. So 1 over 2 over 1 over 1 will give me 1 over 2, right? Then 1 over 4 divided by 1 over 2, 1 over 4 divided by 1 over 2 will give me 1 over 4 times 2, which is still 1 over 2, right? Yes, so I mean, you can do it for about 3 or 4 times and realize that it's all consistent, then you can confidently say it's a geometric sequence. Now, you realize that fine, it's a geometric sequence, but there are some parameters of it, right? And this geometric sequence takes parameters just like the arithmetic one. So you realize that there's a parameter called A, where A is called the first term, right? So the first term here is 1, and there's a parameter called R, where R is the what? Common ratio, right? Now, there are sequences which are neither arithmetic or geometric, right? And it's very necessary you know them, right? It's very necessary you know that there are sequences called that, and you should not try to make a sequence which appears arithmetic or appears geometric into any of those, right? Test first before you try to use any of the formulas we've discussed, right? Now, let's take a look at a limit of a sequence. So an infinite sequence, right, where u of n is from the first term to infinity, because I mean, you have infinite number of terms. That's why it's called an infinite sequence. It's said to have a limit if as n approaches infinity, u of n can be made close to L, right, as we choose, by choosing n sufficiently large. Now, remember I said something about converging, right? We would see example of that later. So for example, when we write u of n, the limit of u of n is as n approaches infinity. Now, this is how you read it. The limit of u of n as n approaches infinity is equal to L, right? That L is a number. The above definition can be more rigorously written as follows. Limit of u of n is equal to L for every element greater than 0, however small, such that a positive integer n depending on this is less than the element. So what they are saying is that as n becomes very large, right, the terms of the sequence approach a number, right, a particular number called L, right, such that when you take that number from that term of the sequence, you also get a very small integer, right. It's understandable if we take example. So for example, we have a sequence and the sequence is 1 over n, right? Now this sequence has a limit of 0. Why? Imagine n continually increasing. Now, so far, you've been doing maths considering infinity as a very large number, but you can just conceptualize it as small number or in increasing steps of number. So let's try n equals to 10. If n is equal to 10, right, or let's try the infinity. Let's say the infinity we are looking at is what? 10. Right, so the infinity we are looking at is 10. Then it means that the sequence would start approaching a limit of what? 0.1. Right. Now let's say our infinity now comes to 100. Then I mean we'll be approaching 0.01. Now you realize that when we increase the infinity point further and further, we'll be approaching 0. Right? will be continually approaching 0. You realize that that our u of n would be 1 over n, which is already defined, and our limit will be equal to 0. Now, the difference between u of n and the limit is 1 over n minus 0, right? Now, we realize that in our definition of the limit point, it should be always less than delta, right? Now, in this case, you realize that then our 1 over n will be always less than what? 1 over 10, right? Then we know that n is what? Greater than 10. So thus, any choice greater than 10 will satisfy the condition required, right? So, for example, if our limit, we were entered our limit to be our limit to be 0.1, right? Then this is the conditions that must hold. It means that at least n should be what? Greater than 10 for the limit to be 0.1 to hold. It all depends on what you are considering as the limit, right? But one thing you must consider is that the sequence will continually approach 0. The next one is this sequence, they say it has a limit of 1, right? Now, there are ways to prove it, right? So, for example, when we take this sequence, right, this is n plus 1 over n plus 1 over n. Now, this can be written as n over n plus 1 over n. Hope you remember this. This is fractions, right? So, when you have maybe a plus b over 2 is the same as a over 2 plus b over 2. So, that's what you see. Now, n over n will give me 1. So, plus 1 over n. Right. Now, do you remember this sequence that we treated above? We said it has a limit of what? 0. Right. It has a limit of 0. What it actually means is that if this one will finally go to 0, that means that the most dominating term will be 1. Right. So this sequence has a limit of 1. Right. Now, this sequence, right, you see, it looks very similar like the one above. But see something. When we use the same formula, that's the same splitting and everything to check it up, realize that we have n squared plus 1 all over n, and it's shocking to see that n squared plus 1 is the same as n squared plus 1 over n is the same as what? N squared over n plus 1 over n, right? Now, n squared over n is the same as n plus 1 over n. Now, you remember this one. We said this one will have a limit of what? 0, like it will approach 0 if the sequence, if n is sufficiently large, right? However, this one, if n gets larger, this n will also get larger, right? Now, in what it actually means is that there has no limit, like there is no bound. This thing will never converge, right? So, in essence, the whole sequence will have no limit, right? Now, if a sequence has a limit, it is called a convergent sequence, like already mentioned, and if it has no limit, it is called a divergent sequence. And those are common terms which are used, and I hope you are familiar with them. Now, there are some theories of sequences. If a sequence u of n has a limit, then the limit is unique, right? It means that a sequence can have only one limit. So, for example, that 1 over n sequence we said, right? Now, you see, someone can come and say, that 1 over n sequence someone can come and say, the limit of this sequence, right, is 0, right? The person is right. Now, someone can come and say it's negative 1. And you are not technically wrong if you see that, right? Because, I mean, this term will never decrease below 0. However, this this theorem kind of says that we are making the limit unique. That is, this sequence can have only one limit, so that we eliminate all possible answers of limit, because once I give an upper bound of a sequence, any other number which is greater than the upper bound automatically becomes the limit, right? But now we are limiting our sense of measure to the least upper bound or the greatest lower bound. Those are the two terms we are using now, right? In that case, then it becomes a unique term of measure. And that's what the first theorem says, right? And I think there's a proof, but there's no need if you understand the concept. So the next part says let u of n and v of n be two sequences such that the limit u of n is equal to a and the limit of v of n be equal to b. Then it follows that when you are finding the limit of the two sequences together, it's equivalent to finding the limit of what u of the separate limit. That is, the limit operation is linear, right? I mean, you might have heard this in previous courses. Probably if you are an engineering student who deals a lot with signals, you probably have heard it. It means that when we say a system is linear, it means that if I operate it on the individual elements, right, it is equivalent to operating it on the whole element, and that's what you see. If I take the individual elements and find their sequence, it's equivalent to adding the what output of the uh, input when they are done individually, and it also works for subtraction too. Now, it's quite peculiar to see that it also works for multiplication as well as division, right? So most of these you see them in examples, so don't bother much, right? For now. Now you realize that the limit operation when the function, right, or the sequence is raised to a power, you can just find it without the power, right? So if the limit without the power is a, I mean then with the power it will approach what the limit raised to the power p. And the examples on this one, so don't bother much. Now that's probably it. I believe we should take few one or two examples to strengthen the connection. So for instance, you are given the limit properties, and I'll be dropping this link so that you can go there and review it yourself. So it says the limit of f of x is equal to 6, g of x is minus 4, and h of x is minus 1. And now these are limits as they approach 0, right? Now use the limit properties to compute each of the following limits. So you have the limit of f of x plus h of x all raised to the power 3. And you realize that this one is combining two properties we studied, right? It is combining the summation as well as it is combining what the power, right? Yes, so that's how they'll be mixing and matching the questions, and it's nothing new. So I mean, when you try to take the limit of the whole thing, it's equivalent to taking the limit of the individuals, right? So we'll take the limit of f of x individually plus the limit of h of x individually, right? Now you realize that the limit of f of x was 6, so we replace it. The limit of h of x was what? Minus 1, so we replace it. And realize that the whole thing was raised to the power 3. Realize that that property allows us, the property just showed here, allows us to raise the limit to a power if we're given, sorry, the limit to a power if we're given that limit value, right? So that's exactly what we are doing. And at the end of the day, we get 5 minus 1, all raised to the power 3. And we get our answers 125. Yes, so that's the end of this session. Continue to like, share, and subscribe. You can continue to ask your question in the comment section so that we review it and we help appropriately. Thank you.